We are going to talk about performance of the computer and how it can be measured and what are the factors that affect the performance of your system. By system, I mean your computer. Okay, these are the main factors which are considered while these are factors actually affect the performance of your computer. First is raw speed of the processor. So if your processor can execute the instructions with high speed, then that would be preferable. That would, of course, improve the performance. Next factor is the instruction set. See, instruction set also matters as the performance also depends upon the instruction set, the number of instructions which are available in your instruction set, then the time it will take to decode those instructions. That is also very important, and that's why it is very the instruction set affects the performance of your computer. Next one is choice of implementation language. So again, which language you choose, that also affects the performance, because when we are talking about the implementation language, if you are using C or C++ or Java, see, for every language the compiler is different, and again the conversion of um, high level language to machine level language is also very important, and this is going to take different amount of time for different languages. That's why it is very important to choose a language very efficiently. Regarding uh, considering your hardwares of your computer. Next point is efficiency of compiler. See, as I just told you, when you are programming, you need to convert your high level language code into machine level language code, and that is the task of your compiler. And that's why it is very important that your compiler works efficiently, so that your performance of the computer can be improved. Next point is skill of programming done to implement the application. See, again, programmers' skills are very important. If let's take one example. Okay, see, I want to write a code to add, let's say, 1,000 numbers. Okay, so I want to perform addition 1,000 times. So there are many methods to do this simple task. Either you can use a loop, or you can use a function, or you can write 1,000 lines. If some programmer writes 1,000 lines for 1,000 additions, then that is going to affect the performance. That's going to take a lot amount of time. I hope you're getting my point. That's why it is very important this the skill with which the programming is done. If your program is efficient and optimum, then obviously the performance of your computer will improve. Uh, Next factor is the clock speed, and last one is instructions per second. Actually, these both factors are related to each other. Uh, and Pulse frequency produced by the clock. See, uh, when we are talking about a computer, it has its own clock cycle. So it can be either 1 microsecond or 1 nanosecond. And that will be considered as one clock cycle. And the number of instructions which can be executed in that period, number of instructions executed per second, that is that will be considered as the speed of your computer. If this number is greater, then we can say your computer is performing with its what can we say, the performance is best by your computer. Now let's see how we can count the rate of instructions. See, first is speed of the processor, pulse frequency produced by the clock measured in cycles per second or hertz. Pulse frequency means number of instructions executed per second. So that will be called as per second or hertz. So for calculating cycles per instruction, we can use this formula. Summation of I equal to 1 to n CPI into II divided by IC. See, you must be wondering what is this II and what is CPII. Okay, see, when we are talking about instructions, there are different types of instructions, and it's going to take different amounts of time for those instructions to be executed, right? If there are types of instructions like data movement instructions, you can either copy data from one place to another place, or you can move data from one place to another place. Those are data movement instructions. Um, Another instructions are like arithmetic instructions, addition, subtraction. Okay, so uh, another type is branch instructions. So these are different kinds of instructions, and these different kinds of instructions take different amounts of time to be executed. Okay, so that's why the cycles per instructions will be different for each type. And II is actually number of instructions of that type, and divided by IC. IC is total number of instructions of each type. Okay, and this is how we can calculate cycles per instructions, average. So this will be your average cycles per instructions. Now, how can we calculate the time needed to execute a given program? So T is equal to IC, the total number of instructions, into average cycles per instructions into T. Now, as some time is spent on the memory transfers, we can rewrite the equation. See, when you are performing an arithmetic instruction, you need to fetch the data from your secondary memory or sometimes primary memory. That's going to take some time. That's why this CPI will be replaced by this formula, P plus M into K and into T. So this is actually uh, the number of times, number of transfers, number of memory transfers, and time taken for each memory transfer. These are these two quantities, and this is your number of cycles average. This is actually the average cycles per instruction plus the memory, the time taken for memory transfers, the clock cycles taken for memory transfers that we have replaced. That now this is how you can calculate time needed to execute a given program. Now, next factor by which you can measure the performance of your computer is MIPS rate. MIPS means millions of instructions per second. So we are just trying to calculate how many millions of instructions can be executed by your processor per second. And for that, this is your formula, IC total number of instructions divided by total time taken by your program multiplied by 10 raised to 6. And if you you can also use this formula. F is actually frequency and CPI is your average cycles per instructions. Now, let's consider this example. See, this is actually your homework. You have to solve this. See, these are different types of instructions. Here you have different CPI times, cycles per instructions, and here you have how these instructions are mixed in the program, the given program. See, this is your problem statement, and please try to solve this problem. And if you don't, if you have any problem while solving this problem, then please contact me. I will obviously help you. Now let's so this is our last point for today's lecture. See, these are actually the benchmarks. It is written in high level language, making it portable across different machines. See, these are actually benchmarks in our computer history. It is representative of a particular kind of a programming style, such as systems programming, numerical programming, or commercial programming. It can be measured easily, and it has wide distribution. We are talking about the operating system which we use for your computers, and operating systems also affect the performance of your computers, and how it is related. Okay, here we will stop today, and we'll study the next part in our next lecture. Thank you.